So for this CockroachDB scale-out demo, I have deployed a cluster on Cockroach Cloud, dedicated, running on AWS. I started with 3 nodes, 4 vCPUs each, 16 gigs of RAM each, 150 gigs of disk, which corresponds to about 2,200 IOPS. And that's my starting configuration. You can see the replicas of the data are pretty evenly distributed across all of the nodes. And if you go to the metrics tab, we can have a look at the currently running workload, which is, by the way, TPCC, and I will show you my actual specs of the workload in a second. So let's start by recording the number of selects, updates, and inserts we have with the current running workload. And also let's have a quick look at the CPU utilization of the current cluster. So we can see it's in the ballpark of around 60-ish across the 3 nodes. So there's a little bit of headroom left for additional workload. And if we now look at the workload I'm actually running so that you can reproduce that yourself, I use the Cockroach workload init TPCC with 1,000 warehouses. Then I ran it, and the workload that's currently running is with 500 warehouses. So I captured the inserts, selects, and updates. I captured the current CPU utilization as well as the results of 3 runs total, and we can see about 6,300 transactions per minute at about, let's say, 170-ish milliseconds of latency. Let's assume that's all right for our workload. But what happens when we increase the workload? Let's assume we have an application and you face additional user workload. So let's bump that up to actually 750 warehouses. So a little bit of more pressure onto the cluster. And we again capture the SQL statements. So again, the selects, updates, and inserts, as well as the CPU utilization across the 3 nodes. And then we can compare those numbers against the run with the 500. We can see that CPU utilization is way beyond the 75-ish range at the beginning. So typically 75% is where you want to consider scaling your cluster. So if we compare that now, we have the 750 warehouses with the same specs running at 75% or more CPU utilization. Obviously, we have way more inserts, selects, and updates, and also like 9,500 transactions per minute, but at the expense of a way higher average latency. Now, that's the point of CockroachDB. You want to lower latency again to improve user experience, but at the same time you want to push more transactions through the system. So that means we need to scale the cluster. And that's what happens next. I again kicked off a TPCC run just for the sake of having a workload running while I'm going to scale the cluster. And I'm going to scale the cluster through the UI of Cockroach Cloud. It's as easy as adding the existing cluster and bumping up the number count from 3 nodes to 6 nodes. That's about it. The remaining specs will remain the same. I'll hit update, and then the cluster goes into scaling mode, as you can see in the UI. Still 3 nodes, but we will see in a couple of seconds that that goes up to eventually 6 nodes. I'll keep this one running. Just a couple of side notes that I went from 3 to 6 because the cluster, or actually the individual nodes, are distributed across 3 availability zones. Hence, we replicate the data across those 3 availability zones. And when I would have scaled it to just 4 nodes, which is totally fine, you can do that. There are certain constraints in place to ensure that we have 3 copies in each of the availability zones. So you would get additional performance, But to make it more, let's say, obvious how CockroachDB can scale, we will see that we will almost be able to double your transactions from the initial numbers we've seen. And therefore I've decided to make a jump from 3 to 6 because that makes it a little bit more obvious, easier to follow. All right, this will take a couple of minutes and I'll just pause my commenting for the time being and I'll be back once the cluster is done with scaling. All right, as you can see, we hit the 6 of 6 live nodes and now also the scaling mode just disappeared. And if we go back to the UI of the cluster, we can see that, for instance, on the CPU utilization chart, the new nodes start appearing one after another. And an important part is that you can see on the overview page that the number of replicas, which were previously evenly distributed across just 3 nodes and availability zones, now need to be redistributed to make sure that all of the nodes carry an even load. And it's easy to follow that process if you go to the metrics and the replication dashboard. So we have now pretty much 2, let's say, lines, 3 coming from the existing nodes, where replicas basically will be pushed onto the new nodes and the number of replicas increasing on the existing nodes. I paused the workload in the meantime so that we can also see, let's say, the CPU activity caused by the reshuffling. So you can see it's not overwhelming the cluster. It runs at, in this particular scenario, not beyond the 25%. And then it dropped to to 0 basically once it was done and no workload was running. And now we can see on the overview page as well that the number of replicas is pretty much evenly spread across all of the nodes. And now it's basically 2 more steps. A, to rerun the previous workload with the 750 warehouses again, which previously provided more transactions in total, but at the expense of increased latency. Now we just repeat the exact same test, same specs, but we will have a look at how latency looks this time. And then the second part being that we bump up the warehouses to twice as much as we had initially. So we go from 500 to 1000, and we'll, to wrap it up, look at those numbers. All right, we give this a little bit of time to get started, to basically ramp up so that we can have a look at the CPU utilization as well as the other metrics. So we can see that in total CPU is way below the 75-80% we had in the previous example. The number of selects, updates and inserts should be pretty much exactly the same, because it's literally the same TPCC run, just performed against 6 nodes instead of 3. So the big change will be if we look at the final numbers. If we look at the final numbers for the 750 warehouses against the 6 nodes, we'll see the same number of inserts, selects and updates, the same transactions per minute, but you can see there is a massive improvement when it comes to the latency. So this would help you already to push the increased, let's say, user traffic of your application, maintain the user experience. But now let's go one step further and assume there will be more users using your service, using your application in the future. So let's push it beyond the 750 and go with 1000 warehouses now. Basically, pretty much same TPCC test. We give it a couple of minutes to ramp up so that we can revisit the CPU utilization, SQL metrics, and then we'll do a final comparison of the initial 500 versus the now 1000 warehouses and how we were able to scale that very, very easily. So here we go again. Now we can see CPU utilization definitely going up with the added workload, which is fine. So kind of expected. Again, if you go to the SQL tab, I just captured again the total number of selects, updates and inserts going through the system while the workload is running. And then we now can have a look at where we ended up with. We started with the 500 warehouses against 3 nodes, 60% CPU utilization, 6,300 transactions per minute at below 200 millisecond latency. Now we are running 1,000 warehouses against the 6 nodes. Same ballpark when it comes to CPU, pretty much doubled in terms of transactions per minute. The latency is not perfectly below the 200 milliseconds, but I would argue for an out-of-the-box scenario where you easily scale out your SQL database, that's pretty impressive. And with that, that's the demo. I wanted to show you how easy it is to scale with CockroachDB. Thanks for tuning in.